Welcome to my presentation on sound, recycling, and transboundary movements of waste, electric and electronic equipment containing critical raw materials. More specifically, I will introduce today CEWASTE requirements which were developed under a European Commission Horizon 2020 funded project called CEWASTE. This project runs until March 2021. My name is Sonia Valdivia and I work at the World Resources Forum Association. In order to address the main challenges, not only in Europe but also worldwide, of inefficient and unsustainable recovery of critical raw materials from e-waste, following deliverables were developed under this project. A gap analysis, which is already available in the CEWASTE website, the CEWASTE requirements, which I am introducing in the following slides, and a certification scheme which bases on the deliverables developed under the project. The CEWASTE requirements have a global scope and aim to help improving the recycling and increasing the recovery of CRM from WEEE, including batteries. These requirements are of 4 types: managerial, sustainability, traceability, and technical requirements for collection, logistics, and treatment facilities. Concerning the approach, we took consideration of the following. Main findings of the gap analysis report indicated that the SENELEC standard 50625 series is the most comprehensive and suitable set of standards for the purpose of CEWASTE. Based on that, these standards were adopted as a starting point. In cases where guidance in the SENELEC 50625 series were not sufficient, other international standards and guidelines were considered. For example, the ISO I-118 for the sustainable recycling of metals and the Basel Convention for lead-acid batteries and transboundary movements. The requirements are developed for WEEE and waste batteries operators in the value chain, including collection points, facilities, logistic operators, pre-treatment, and final treatment facilities. When talking about critical raw materials, we refer to the European list in their communication of 2017. And we also refer to valuable materials, such as gold and silver. Our consortium developed new texts for the following areas where no requirements exist, such as technical requirements for waste batteries, waste magnets, fluorescent powders, and printed circuit boards. Other groups of requirements include the traceability ones, upstream, and the sustainability requirements. These areas were identified as gaps in the global mapping report of the project. 6 overarching principles guided the development of the new requirements and articulation with existing ones that were adopted from the SENELEC standards. 3 out of the 6 principles relate to technological feasibility, economic feasibility, and the optimal collection, sorting, and removal of critical raw material, which are closely related to the technological clause. The other 3 principles are more linked to the managerial requirements, such as their contribution to continuous improvement, their capacity of being verified through audits, and their capacity to support tracking compliance of fractions transfer throughout the value chain. For developing requirements for the 4 components identified before, waste batteries, magnets, fluorescent powders, and PCBs, then there needs to be a very clear identification of the key equipment containing them. So we are talking about key CRM equipment here in the rows, which contain key CRM components in the columns. Let's see one example. Waste laptops contain lithium-ion batteries, here in green, neodymium, magnets in light blue, and PCBs in red. Continue with example. For laptops, we can also identify the critical raw materials and valuable materials that can be recovered. Cobalt and lithium can be recovered from lithium-ion batteries, for example. These are in green. Gold, silver, palladium, and other CRM can be recovered from printed circuit boards, here in red. And neodymium and rare earth metals can be recovered from waste magnets, here in light blue. These are very clearly in the middle of this table. Considering their hazard properties and potential risks to health and the environment, the toxics contained and released during the depollution and treatment are also crucial. Again, for this specific case of laptops, see that flame retardants outstand among the main toxics that can be potentially released when treating printed circuit boards. The current structure of the CEWASTE standard document is similar to the one defined under the CENELEC 5625 series. This is done on purpose in order to make the use easier to current users of the CENELEC standards, and also in order to facilitate a possible revision of the CENELEC standards based on the CEWASTE proposal, if this is decided later. The document, the CEWASTE standard, considers two central clauses. Clause 4 with managerial, sustainability, and traceability requirements, and Clause 5 with technical requirements. More than 80% of requirements under the Clause 4 is considered new text with respect to the CENELEC standards and other international ones. Texts were mostly developed by consortium members and considers feedback from the open consultation held early 2020. With respect to the traceability requirements under Clause 4, this is compulsory for lead-acid batteries and printed circuit boards, considering their higher environmental and social risks along their value chains and following the strong recommendations of stakeholders. Traceability is based on the due diligence approach, which is supported through second-party verification audits of suppliers upstream, such as pretreatment facilities, logistics, and collection operators. Sustainability requirements complement the traceability, managerial, and technical ones. Sustainability aspects mainly cover the environmental monitoring and controls. These were specifically developed for the waste batteries, waste magnets, fluorescent powders, and printed circuit boards. Other sustainability criteria elaborated under this clause refer to contributions to the local community and the society, which are not obligatory. They remain as recommendations. The technical clauses also follow a very similar structure as defined in the CENELEC 5625 series. Users of this series might have quickly identified the similarities, though with several additions. For example, shipping addresses logistics requirements and transboundary movements of wastes, materials, and fractions. This clause is especially relevant for hazardous components such as lead-acid batteries and fluorescent powders, which fall under the list of wastes of the Basel Convention guidelines for transboundary movements. Proper sorting of the different components, as introduced before, is key for improving the critical raw materials and valuable materials recovered. Final treatment of the 4 key CRM components identified need to take place in proper facilities that follow the CEWASTE requirements. We acknowledge that some final treatment processes are state-of-the-art, such as for PCBs treatment, while others are at an early stage of implementation, such as for waste magnets. Through the laptop example, we can see how to navigate through the requirements. As any other WEEE waste laptops are shipped to collection points or collection facilities, where they are separately collected. That could be in special containers or separated protected areas. Collected waste laptops are then shipped to pretreatment facilities where they can be sorted following a more detailed assessment of their condition and content. For example, if there is a possibility of reuse, used laptops are prepared and then sent to corresponding facilities for refurbishment or repairing. The reuse option and corresponding facilities are outside of the scope of CEWASTE. Let's say the used laptop cannot be reused. Then this laptop automatically becomes a key CRM equipment as defined in this standard and hence undergoes the next treatment steps. In the pretreatment facility, the key CRM components are clearly identified as explained before. For the laptops case, they contain waste, PCBs, magnets, and lithium-ion batteries. Assuming no hazardous substances need to be removed from these laptops, the key components can be directly removed and separately sent to the corresponding final treatment facilities. These final treatment facilities succeed in recovering the valuable materials and critical raw materials as expected. The current version of the CEWASTE standards are undergoing, since September this year, a pilot testing, which will last 2 months. Findings from the pilot testing and feedback from an additional online consultation that will be held in January 2021 will be taken into account for producing the final version. The CEWASTE standard will be published in March 2021. Please take into account these important dates. I invite you to participate in January stakeholder consultation of the CEWASTE standard. If you are already registered in our stakeholder list, you will automatically receive the invitation in due time. If not registered yet, you can use the contact details given in the slide. Thank you very much for your attention and looking forward to your comments, looking forward to your questions. As explained, they will be forwarded to us by the organizers. Thank you.